Hey there, John Harvey with Fort Lewis College's Geosciences Department, here with an analysis of the October 9th through 12th rain event that just hit the San Juan Mountains here in southwest Colorado. So this all started when Tropical Storm Priscilla here started spinning off the coast of Baja, Mexico, followed by another shortly on its heels. In this satellite animation, we can see the remnants of Priscilla spinning and the moisture from that storm getting fluxed into western Colorado, really the whole Four Corners states. And the loop continues through the storms that are continuing today. So we have a tropical moisture getting sent by Priscilla into the Four Corners area. And another way to look at that is to look at the relative humidity of the atmosphere. The closer it is to 100%, the closer it is to raining. And here we can see Priscilla sent quite a wave of high relative humidity air into our part of Colorado. The mountains of southwest Colorado are really the San Juan Mountains here, and the western San Juans wrapping around to become the eastern. And the towns of Durango, Bayfield, and Pagosa Springs sit along the rivers that drain out of the San Juan Mountains. And the way these mountains really rise up out of the plains helps to squeeze moisture out of the atmosphere as storms smack into the mountain range. And that's exactly what happened. This is a storm total from the first wave of the storm, showing that a broad area of the San Juans got 2 to 3 inches of rain, with some higher amounts of 4 and 5 inches in the high country, and a highest recorded number of 6.5 inches from the upper San Juan Snowtell site over near Wolf Creek Pass. So a lot of water coming out of this storm. For many of these areas, this is kind of multiple months worth of rain coming in at once. So if we look at that upper San Juan Snowtell in blue, we can see the accumulation of rainfall that occurred throughout the storm. And then in red, we can see how the San Juan River, responded to it. So the first wave of rain brought about 1.8 inches on October 9th, and on the 10th, we had the second wave of rain, which brought in almost 4 more inches to that station. And as these 2 waves of rain came in, we could see 2 big pulses on the river, with the second one culminating at over 8,000 cubic feet per second, which sent quite a wave of water down into Pagosa Springs and beyond. The river's come down quite a bit since then, but before it did, it left its mark. So here's a view from a drone shot from Gabe Priestley, showing the Springs Resort in downtown Pagosa Springs, largely underwater, with this swollen river coming up close to the pedestrian bridges in town. If we look at all the regional rivers, we can see that the San Juan was not the only one to have a big peak. Vallecito Creek hit nearly 7,000 cubic feet per second, which was also nearly a record. Certainly a record for that date, but almost a record for that creek in general. The Animas River and the Piedra River got well into 4,000 CFS. The Dolores River did not show as much, but that's because it's on the west side of the San Juans and did not have as much favored terrain, helping to squeeze water out of the storms that were traveling more south than north. So a lot of rivers experiencing their peak of the year, reaching higher than they did during the spring and summer snowmelt. Vallecito Creek was damaged, or the areas along it were damaged. Over 380 homes had to be evacuated, and according to La Plata County, more than 100 homes are thought to have sustained water damage. So the question is, after an event like this, it's commonly something to do with climate change. Did climate change make this worse or cause it to happen in the first place? The beginning of the answer to that question is no. This is not what caused it to happen in the first place. In fact, the biggest flood of record on all these rivers occurred in 1911 from a similar storm that spun into the San Juan Mountains, long before climate change, as we normally talk about it, was beginning to rear its head. So climate change didn't cause this event, but then you could ask the question, did climate change make it worse? And I do think there's a chance of that. So let's take another look at Priscilla and the moisture from that storm. This time we're looking at it in the form of precipitable water. This is showing the total amount of water vapor in the atmosphere. If you rained it all out, what depth of water would you get? And so we can see the high values around the storm itself, like 3+ inches of precipitable water. As that water makes its way into southwest Colorado, we see numbers that are more like 30 to 40 millimeters, so more like 1 to 2 inches of precipitable water. Now, that might not mean that much. Another way to look at it is to look at it as the anomaly, precipitable water anomaly. So how much more water than normal was there in the atmosphere? And we can see that as that first wave of moisture comes in from that tropical storm, we're hitting numbers that are kind of at the upper end of the spectrum here in terms of wetter atmosphere than normal. So this is discussed by the forecasters at the Grand Junction Forecast Office of the National Weather Service. They talked about there being precipitable water values of 350 to 400% of normal. And that kind of led them to issue flood warnings across the region before the storm even hit. So where does all that precipitable water come from? Well, we could start to look at the sea surface temperatures in the area where this storm occurred. This is a map showing how much warmer or colder than normal is the ocean surface. So we can see some cool areas in the tropical Pacific, warmer in the North Pacific. But if we zoom in on the eastern Pacific there, these storms, Priscilla and its follow-on, are originating from Baja. And you can actually see the formation of these storms as this cool water starts to appear. That's the kind of result of this storm taking quite a bit of the heat away from that surface water. And before the storm show up, though, we can see that we had sea surface temperature anomalies as high as 4 degrees Celsius. So that's almost 7 degrees Fahrenheit warmer than normal for the ocean temperature where this storm originated. So one might be able to make a connection here where the rainfall we got was enhanced due to higher than normal precipitable water values, which themselves were enhanced by higher than normal sea surface temperatures off of Baja, Mexico. So this could just be one way that climate change impacts southwest Colorado, is by sending a bit more water this way when we get a storm like this. Thanks.